All right, guys, we are going to do the last part of Unit 4, which is going to focus on ions. You should have already done the simulation, which will hopefully allow you to make some big connections as we go through this information on ions. So just a reminder, in a neutral atom, okay, which is all we've dealt with up until this unit, neutral atoms, the number of negatively charged electrons must equal the number of positively charged protons. And one big thing is that protons is always represented by that atomic number. So when we talk about ions, the protons are always locked in place because it's the same element. So protons, which determine the element, and is represented by the atomic number, is constant. So when we talk about ions, it's going to be all about this changing the number of electrons. And this is going to become important because while we've talked about valence electrons and how they're going to influence properties, we're going to see how forming ions can also influence properties and bonding. So we'll be getting to that. So when atoms lose or gain electrons, and specifically, again, we're only talking about electrons, they're going to become charged ions, meaning they become a positive ion or a negative ion. So students struggle with understanding positive versus negative ions and not thinking about it in terms of a positive being addition or negative being subtraction. It's actually the opposite of what you naturally want to do. You want to think about it in terms of charges. So all of these have 5 protons. Okay, so that means we have boron. So we're just using boron as an example. If we have 5 protons, you'll see that's the same. So 5 protons, 5 protons, 5 protons. And we're just going to talk about how gaining and losing electrons will influence the charge. So with this, I have my 5 protons, and then I have an equal number of electrons. So this would be your atom. Okay, because I have 5 positives and 5 negatives, they cancel each other out. So that's why atoms are neutral. Okay. However, if I lose an electron, okay, I still have my 5 protons, but now I have 1 less electron. So when you think about them canceling it out, you're left with an extra positive charge. So when you lose an electron, and again, think of these as you have 5 positives, 4 negatives, okay, I have less electrons now, they're no longer equal. That means I'm going to create a positively charged ion. Okay, so losing electrons create this positive ion. And specifically for this one, I would have a +1 charge. And this is where students struggle with. Don't think of that as addition. It's a charge. So that positive is kind of independent of the 1. This is saying that I have a positive 1 charge. I did not add in electrons, remember? I lost them. So it's, again, kind of opposite of what you naturally want to do. When you go over on this side, okay, now we still have our 5 protons. Okay, but I can see now I gained an electron. So here I've added in an extra electron. So as we went over here, I gained an electron. Okay, so I originally had, again, my 5 positives, but instead of my 5 negatives, I now have 6 negatives. Okay, so when you think about canceling out those positives and negatives, I have 1 extra negative there. So when you gain electrons or you add electrons in, it actually creates a negative ion. Okay, and if we looked at this particular ion, I have 1 extra negative. So this would be a 1 minus, or again, I try and think of that as more of a negative charge. Okay, and you can put the plus and minus either before or after. I actually try to put it afterwards so you're not thinking about it as adding or subtracting as much. But again, remember in this case, the -1 charge does not mean you lost 1 electron. It's actually because you have an extra negative electron because it, again, gained it. Okay. All right. So let's look at a couple other things quickly. When an atom loses 1 or more electrons, we already talked about how it actually becomes a positive ion. And what we're going to see is because it's losing those electrons, it's actually going to create a smaller ionic radius. Okay. So it actually loses the whole outer shell, which we'll be going back to when it loses its negative electrons. If it gains 1 or more electrons, we already talked about this is then going to create a negatively charged ion. So a negative ion is formed. And when we add in these electrons, and we'll get into the explanation when we get in periodic table of why, this is going to create a larger atomic radius. Okay, if you start putting in more electrons there, they're going to take up more space, and it's actually going to increase the atomic radius as those are added in. Okay, and then we'll get into Lewis dot diagrams of ions when we get into our next topic. So let's look at some examples of just how does this influence how we calculate protons, neutrons, and electrons. So this is really important, so make sure you pause it if you need to. So here I have my isotopic notation. Okay, my number of protons is always going to be determined by the element. Okay, so I always figure out that one first. Strontium is going to be atomic number 38. Okay, and then that again is the atomic number. Oh my goodness. My atomic number is 38. The neutrons, remember, is going to be this mass number. Okay, so that's going to give me my number of neutrons. So neutrons is going to be 88, my mass number, minus 38, which is my protons, which is going to leave me with 50 neutrons. All right, and then electrons is usually, again, at this point going to be the trickiest. So originally, if this was neutral, I would have my positive 38, and I would have my negative 38. So this would be if it was an atom. Zoom in on that a little bit more. Okay, but in this case, I have this +2 charge. So what I usually like to think about is, first off, it helps if you realize, oh, positive ion means that I lost electrons. The other thing would be, okay, if I have 38 positives and 38 negatives, okay, in order for me, if that 38 is locked in place, the only way I can get a +2 charge is if I take out 2 negatives, okay, which would mean then that I would have this 36 negative electrons there. So I would need 2 less electrons because it lost 2 electrons when it formed this +2 ion. Okay, let's go the other way. So with protons, I'm looking at, I have 39 protons, okay, which if I look at 39, I have yttrium. Okay, so this would give me my symbol. Okay, my mass number is going to be the sum of the protons and the neutrons. So this gives me my mass number. So this 39 plus 50 is going to give me 89, which goes in the upper left. Okay, and then if I look at these two numbers, I have 39 positive protons. I have 36 negative electrons. So if I think about canceling those out, I get 3 extra positives there, which is going to cause the +3 charge. Okay. All right, let's look at some negative ion examples. Okay, so I'm going to go over here. So same idea. Protons is going to be based on that symbol for N. So I'm going to look up neutron or nitrogen, okay, which is right here. It has atomic number 7. So that gives me my 7 protons. That is locked in because it's nitrogen. My neutrons is going to be using this 14 number. So 14 minus my 7 protons happens to give me 7 neutrons. And then my electrons. So let's go back to and talk about, if this was neutral, I would have equal amounts. Okay, that would be if it was an atom. Okay, but it has a charge. Remember that 7 plus is locked in. If I take out negatives, I would be left with a positive ion, but I have a -3 ion. So this has to gain electrons, okay, in order to end up with 3 extra negatives there. So in this case, I want to say, okay, I have to gain electrons and I have to gain 3 of them so that I get up to 10 electrons. And if you check that, if you have 7 positives and 10 negatives and you cancel them out, you're going to have those 3 extra negative charges there. All right, and then our other example here, let's go backwards. My protons here are going to give me my symbol again. So if I have a 53 there, 53 atomic number, it's going to give me iodine. Okay, I'm going to add these together to get my mass number. So this would give me 5 and 2, so this would give me 126. I added my 53 and 73 correctly. And then when I go to look at the charge, in this case I have 53 positive protons, I have 54 negative electrons. Okay, I have 1 extra negative here, which means that's going to be my charge, so -1. Okay, so this takes some practice and work for a lot of students, so don't get frustrated by it. But again, the more you can think about it in terms of charged particles, the better. This little part at the bottom is just for you to realize that there is some periodic trends involved with this. We talked about when we did our valence electrons and Lewis dot diagrams that elements in the same column have the same number of valence electrons, and we're going to see a similar pattern when we talk about ions. So metals, which are to the left of the staircase, these guys are going to tend to lose valence electrons and tend to form positively charged ions because of it. We're going to see with our nonmetals, with the exception of our noble gases, these guys are going to tend to gain valence electrons when bonding and create negative ions. So you're going to see that due to elements having very similar number of valence electrons, they're going to tend to form similar ions, which can be helpful as you start to kind of go through that. Okay, so we're going to keep working on this. Let me know if you have any questions.